Hello, my name is Jose Parra. Today we're going to be looking at for loops, while loops, and nested for loops. We're going to be looking at their purposes and how we can use them in our codes, and we're going to see how we can use them to calculate the modulus of specific numbers, and in the end we're going to try to see which one would be more beneficial in which case. First we're going to start with a for loop. We use a for loop when we know how many times we want something to be iterated or performed, meaning that if we want something to be performed 4 times, we would use a for loop because we can control how many times the body of the for loop is performed. My example in this case would be we're going to do a for loop that says for integer I equals 1, meaning I starts at 1. The body I plus 3 mod I is going to be performed as long as I is greater than 6. And then we add our control, meaning the how many times we're going to be iterated. So we say I plus plus, meaning we want I to be incrementing continuously until it doesn't meet this condition. Let's see how this looks. So we're going to do n dot for loop, and we should be getting six calculations because it's going to be iterated 6 times. So as we can see here from our results, when we say 1 plus 3, which is 4, 4 mod 1 is equal to 0, 5 mod 2 is equal to 1, and so forth, where remember in this case it's I equals 1, I equals 2, I equals 3, I equals 4, I equals 5, and I equals 6. That allows us to be able to create the mod of those specific things. Next, we're going to be looking at while loops. We can use while loops when we don't know how many times we want something to be iterated, meaning that we create a while loop to say do this action until it doesn't meet the requirement or the like a constrictor. The one thing with while loops that we have to be careful with is that if we don't put something to be able to stop the while loop, you will have an infinite loop, meaning it's going to be it's going to be doing it over and over and over again because it's never going to go past the bounds or the restrictions that we have it. In this case, we're using a scanner allowing a user to input a number, and it's going to calculate the mod of that number starting from 0 up to the number they picked. So we first start by defining our I to be 0, our j to be 5, and our k to be the user's input. So our while loop now states that while I is greater than or equal to the user input, meaning the number they pick, it's going to perform the body of the program, or of the while loop, which is just saying I mod j. Since we know j is already 5, this means you're going to do 1 mod 5, 2 mod 5, and so on up until the number that they decided to input. And here we have our I++, which allows the I to be iterated, or you're adding 1 to it continuously to be able to reach the however many times you want it to be performed, and so it can reach a breaking point. Without this, we would get an infinite loop. Let's see what this looks like. So we're going to do n dot while loop. So now it's asking us for input, meaning up to what number do we want to calculate the mod 5 of it, starting from 0 all the way to that number. Let's use 16. So as we can see here, we say 0 mod 5 is 0, 1 mod 5 is 1, 2 mod 5 is 2, and so on, up until we get to 16 mod 5 is just 1. This allows us to calculate a long range of mod 5s, which allows us we can modify to calculate any mod for any range of numbers. Next, we're going to do a nested for loop. We can use the nested for loop to be able to create a program or a method that's going to be able to create a mod of any variable as long as it meets within those conditions. In this case, we say that the for loop, our initial for loop that says that I is equal to 1, and it's going to say it's going to perform the rest behind it and the embedded for loop as long as I is greater than or equal to 15, and this is going to be iterated 15 times. If this initial condition is met, then we're going to start to be able to perform I mod j. And to perform I mod j, we have another for loop where we're going to define the values of what j can be. So we can say for j that starts at 1, this for loop is going to be performed as long as j is greater than or less than or equal to 2, and we're going to iterate j, meaning we're going to do 1 and 2. If these conditions are met, then we're going to be able to do I mod j, meaning we're going to do 1 mod 1 because it starts at 1, and we're going to do 1 mod 2, and so forth up until we get past 15. Let's look at what this looks like. So we're going to do n dot nested for loop, and we're going to see how it's going to be performing this action multiple times. As you can see here, it performs it multiple times, but it's performing it for 2 different mods all the way up to 15, meaning 1 mod 1 is 0, 1 mod 2 is 1, 2 mod 1 is 0, 2 mod 2 is 0, 3 mod 1 is 0, 3 mod 2 is 1, and so on up until we get 15 mod 1 equals 0 and 15 mod 2 equals 1. This allows us to be able to run 2 different mods at the same time and calculate the wide range of the arithmetic. So in conclusion, we can see that for this case, our more beneficial ones would be either the while loop or the nested for loop. The while loop allows us to create a long list of a specific mod, while the for loop, we can create a long list of 2 different types of mods, which allows us to a lot of creativity with how much or how far we can calculate the modular arithmetic of the mod of numbers. Thank you. Have a good